Simplifying. Today we're just working on simplifying. So simplifying radicals. Well, before we simplify it, we've got the parts of a radical. Sometimes we call it a root. It's the same thing. Roots, radicals, same thing. Okay? The sign, the actual sign. Kind of looks like a division sign, but it's not. The stuff underneath. The stuff underneath the sign is called a radicand. It's just the stuff underneath. Okay? The stuff in front is called the coefficient. The root itself is called an index or a root. Okay? Now, if that number is not there, it's always going to be 2. Square root, right? So if you go on your calculator, if you look at, let's see, where's my calculator at right here. So if you go to your calculator or Delta Math calculator, you have 2 root buttons, right? You have 2 root buttons. One is nothing above the root. That's the square root, right? The square root of 64. Like I said, if I want to do square root 64, oops, right? That's 8, because 8 times 8 makes 64, right? Third root gives me an option. Now, if I put the 3 up here, and I say the third root of 64, that's 4, because 4 times 4 times 4 makes 64. We're looking for triples now. It's not pairs. Square root is pairs. Third root is triples. If I did the fourth root, that means what times itself 4 times makes 64. And it's a decimal. Okay? So that's what that means. That's what those numbers mean, those little numbers. If there's nothing there, it's a square root. 2. Okay, so steps on how to solve it. Well, there's 4 steps. First thing we're going to do is break down everything. Everything that's underneath the radical, break it down. Okay? And then we start circling things, and then we'll start taking things out, leaving things in, and we'll be done. Okay? It's not a lot of steps, but they're important. Okay, so the first one, example number 1. Simplest. That means simplify. Okay, so 112. The only thing underneath the root is 112. So that's what we got to simplify. So the first thing we're going to do is break down 112. What do I mean by break down? Break down means factor tree, the little trees with the branches that you guys have done since elementary school. 112 and then little tree there. What times what makes 112? There's a lot of things that make 112. We're just looking for 2. The only ones that won't work right now are 112 and 1. So let's see. Let's see. 112. How do we make 112? Let's see. 112 divided by 2. There you go. 56 and 2. So I'm going to go back to my tree, and I'm going to put 56 times 2. 56 and then 56. I can still break down 56. 56 is 7 times 8. Okay. How about 2 up here? I skipped 2, but 2. Can I break down 2 any further? Is there any way to break down 2 any further? Just 2 times 1, right? So when that's the case, when you could only break it down by itself in 1, you circle it, because I've broken it down as far as I can. 7, can I break down 7? No, circle it. Break down 8, 4 and 2. We do that until we can't break down anymore. And we get a bunch of prime numbers. Oops. That's the first step. First step is always that. All right, guys, so all of this stuff I circled is broken down, right? That's broken down as far as I can. So I'm going to put it back underneath the root. Okay, so I got a 7, and I got a bunch of 2s. I got 4 of them. So what do you think I would get if I multiplied 7 times 2 times 2 times 2 times 2? What do you think I would get? 112, right? 112. So it's not different. Just looks different, right? It just looks different. It's still 112. This is still 112. That hasn't changed. Okay. That leads me to step 2. Step 2 is circle pairs or triples of 4 of a kind. How do you decide which one you're going to circle? Depending on the root. Which root does this guy have? Which root does this guy have? Square, right? It's 2. If there's nothing there, it's always going to be a 2, which is another name for square root, right? Another name for square root, okay? That means we're looking for pairs. So I'm going to circle the pairs. Pair there. Pair there. Okay? Which leads me to my next step. My next step says I can take out one representative for each circle. Each circled pair, I can take out one representative in front.
So if it's a square root, we circle pairs. If it's 4, we circle.
Exactly. Yeah. If that number right here was 4, we would look for 4 of a kind. So I would look for, I'd have only one 4 of a kind. Yeah. For sure. Okay. So I have 2 pairs. So I'm going to take out a 2 here and a 2 here. I can only take out one representative, one per pair, or one per 3 of a kind. Okay. So I have 2 and 2 in front. What do you think those 2 and 2 are going to do? Multiply. Yeah, they're going to multiply. Anything I take out to the front, they multiply. What's left? 7. That guy did not have a pair, so he's got to stay. So when I multiply, I get 4 times root 7. You're done. That's simplified. Simplified as far as it can go. There are no more pairs. This whole thing is try to take out pairs. Like Bruno just said, if it was a 3 or a 4, I would take out triples or 4 of a kind, whatever the root is. That's what this process is, right? But you don't know. You can't look for pairs or triples or 4 of a kind until you've broken everything down. Until I break everything down, I can't look for those things. Okay? All right, so go to number 2. Try number 2. Try number 2 right now. Use the same steps we just did for 96. And I'll do it with you guys in about 2 minutes. Okay? So same steps. So I started with 48 and 2. You don't have to start with 48 and 2. You can start with 12 and 8. You can start with 24 and 4. You can start there's lots of things to start with, but you'll always end up with the same number circle. Okay? So 48. So if I break down 48, again, there's a couple different ways to break down 48. It doesn't matter which ones you use. 24 and 2. Circle the 2. 24 is 6 times 4. 6 is 3 times 2. 4 is 2 times 2. Okay. So when you're done, it doesn't matter where you started. When you're done with 96, you should have 5 2s and 1 3. We're going to put those back in. A 3, 2, 3, 4, 5. Okay. This one's a square root again. It's square because there's nothing here. So I'm looking for pairs. Pairs. So I'm going to circle pairs. I got a pair of 2s, pair of 2s. 1 2 can come out for each pair. So 1 can come out here and 1 can come out here. So I have a 2 times 2 in front because those are the 2 2s that came out. What I have left over is a 3 times 2. What is 3 times 2? 6. So we get 4 root 6. Okay, the reason 6 has to stay is because 6 doesn't have any pairs. It's just 3 times 2. All right. Okay, so number 3 now. Number 3 kind of ups the ante a little bit because instead of just numbers, you got letters too. But in math, what do letters mean? Why do we use letters in math? What do they represent? Numbers. They represent numbers, right? Letters represent numbers. We just don't know what numbers they are, right? So x to the 6th is something times something times something times 6 times, right? That's all it is. So what do we start? Well, we start the same place we started last time. Start with the number, 54. So let's start with 54. Break down 54. So 54, let's see, 9 times 6. 3 times 3. Circle the 3's because they can't be broken down any further. 3 times 2. There we go. So I got 3 3's and a 2. I'm going to go put those back in. Everything else is going to stay the same. Okay. Look for pairs. This one's pairs again. There's nothing there, so it's a square root. So I'm looking for pairs. I got a pair of 3's here, and that's about it. So I have 3x on front. Then I have 6, right? 3 times 2. Then I have x to the 6th and y to the 5th. What is x? So like, let me kind of take a little bit of a left turn. If I had x squared, what does that mean? What's another way of thinking about x squared? How do I make x squared? We've done this before with the box, right? How do we make x squared? Yeah, x times x, right? And then if I did x to the 3rd, how do we make x to the 3rd? Right? So the one we're dealing with right now is x to the 6th, right? So isn't that just x times x times x 6 times? Same thing with y. So in other words, this is like this. 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5. That's what that means, right? That's how to break down x's and y's. Letters. That's how to break down letters using multiplication. Well, guess what we're going to do with the letters? Same thing we did with the numbers. Circle them. Yep, pairs. I got a pair of x's here. I got a pair of x's here. I got a pair of x's here. I got a pair of y's, a pair of y's, and then I have one y left over. So let's see what I can take out. I can take out an x, and another x, and another x, and a y, and another y. So let me take those out. So with the 3x, I have 3 x's that I took out, right? And 2 y's. I have 3 x's that I took out. One was already in front. One was already there. So I had 3 x's I took out, and I have 2 y's that I took out. What's left underneath? 6 and y, right? One last thing. This guy here, instead of having to write it like that, what's another way of writing it? 3x to the 4th power and y to the 2nd power. You're done. You're done. Here's my question. which is probably your question. Do I have to write out all of those x's and all of those y's? Because look at the next one. How many x's and how many y's do I have? That's going to be a long list, right? Do I have to? My answer is there another way? Is there another way I could have done that same problem, but instead of writing out all the x's and writing out all the y's, done it in my head? Use division, right? You can use division because I'm looking for pairs, right? That's division. If you're dividing something by 2, you're really just saying how many pairs are there. Like if I have a number like 16 and I'm looking and I asked you how many pairs are there in 16, that's just really 16 divided by 2, right? Excuse me. So it's division. So I had 6 x's here, right? If I divide those by 2, how many pairs would I have? 3, which I took out right here, right? Those are the 3 I took out. And then I had y to the 5th. How many pairs do I have there? 2, right? And then I had 1 left over, right? That's another way to do it. We can do it that way without having to write. Now, that being said, I have students who write out all of these, and guess what? They never get a problem wrong because this is the best way to do it. There are shortcuts, okay? And I'm going to show you the shortcut on the next one, which we just talked about, right? We're looking where you divide these guys. Just be careful with the shortcuts because the shortcuts sometimes can mess you up sometimes. Okay, so I'll do the shortcut way on number 4. Do the shortcut way on number 4. Okay, so number 4, what's the difference between number 4 and the ones we've just done before? The 1, 2, and 3. We're going to be looking for triples. Yeah, we got a new root, right? We got 3 now. We're going to be looking for triples. Same game. Steps stay the same. We're just looking for triples. That's it. Okay. All right. So the first thing is the number 750. We got to break that down. Okay. Doesn't matter where you start. Just use your calculator. You can divide it by 2. You can divide it by 5. I think the easiest way is to divide it by 10. Any number ends in 0 can be divided by 10. So you get 75 and 10. And then 75 is 25 times 3, or 15 times 5. 3, I need to circle because it's prime. Can't be broken down any further. Same thing with the 5s. The 5 is prime. What I mean by prime is it can't be broken down any further. It's just going to be 5 times 1, 3 times 1. Then I got to go back. 10. 10 is 5 times 2. And 5 and 2 can't be broken down. I'm going to go replace 750 with those numbers I circled. I'm going to rewrite everything. Y squared, third root. Instead of 750, I'm going to write 5 times 5 times 5 times 3 times 2. And then x to the 10th, y to the 10th. Just like you guys said, this one's triples. We're looking for triples. So I'm going to circle triples. I got triple 5s. So triple 5s are going to come out. So I have 5y squared the 3 times the 2 has to stay because 3 doesn't have a triple, 2 doesn't have a triple. So 3 times 2 is 6. X to the 10th. Again, you can write x times x times x times x. That's okay. That'll work. But let's try to use the shortcut. How many triples is x to the 10th going to have? 3. How many x's are going to be left over after I take out those 3 triples? 1. Y to the 10th is the same thing. It's going to have 3 triples. And it's going to have 1 left over, right? Okay. Clean up the mess in the front. I have 5 x to the third, right? X to the third, because I have x times x times x. What is it going to be? Y to the what power? To the 5th power, yeah. To the 5th power, because I already had 2 to begin with. And now I'm including 3 more. Y to the 5th power. And then the third root of 6y xy. You were done.
Does it matter if you put 5x to the third power before y to the 5th power?
No, you can switch. Since this is all multiplication, right? These guys are all multiplication. You can switch order. Usually we put the number in the front, and usually we put them in alphabetical order. But if I put the y to the 5th here and the x to the 3rd there, is it wrong? No. Nope. So a couple things. Be careful, because on Delta Math, sometimes this guy here, the root, can look like a power. And so you'll put your answer in, and it'll say you're wrong. And you're like, what? That looks exactly correct, because you put this in as a power. Make sure you put it in as a root. So in Delta Math, it's going to have one of these 2 buttons here. The roots, we use the first one if I just want a square root. The second one if I want a third root, but then you got to put in the 3. Okay, so just be careful when you're putting those in. So this guy right here, if I was putting in my answer, I would put 5x to the third. Well, let me do that. Let's see. Well, let me do that. Let's see. 5. I don't think it'll let me do letters. Yep, it will. X to the third power. Y to the third power. Or wait, to the 4th power. 5th power. And then I would use the root. Put a 3 there. And I would have a 6 xy. That's how I would put it into Delta Math. You see how the 3 and the 5 kind of, sometimes that could be a little confusing. Okay, so just be careful when you put it in to Delta Math, because sometimes it reads it differently than what you think you put in. Okay, so let's go to the last page. So simplifying, we're still simplifying. 5, 6, and 7, we're still simplifying. The only difference is we have a pre-step. We have to do something before we get to step 1. I can't break down yet. Why can't I break down? Well, I have to simplify it a little bit. Okay, so what is the product? It says, what is the product of this guy and this guy? Let me ask you a question. What does product mean? Multiplication, right? So I got to multiply. I got to multiply the purple and the green. Well, I have a 10 on the outside, a 10 on the inside. I have a 4 on the outside, a 12 on the outside. What do I multiply? Here's the answer. Multiply what's on the outside with what's on the outside. So you can multiply outside numbers. 10 and 4, I can multiply. 40. Numbers on the inside, you can multiply as long as they have the same root. So 10 and 12, are they both have the same root, square root? They do. So I can multiply those to make the square root of 120. 10 times 12 is 120. So insides times insides, outsides times outsides. Now I can go to step 1. Now I can go to step 1. I can break down everything under the root. Do I have to break down 40? The answer is no, you don't have to, because it's not under the root. The only thing you have to break down are things under the root. So 120 is under the root. So I got to break down 120. Okay, a lot of ways to break down 120. 60 times 2, 12 times 10. Anything you want to start with. It doesn't matter as long as it's correct. And you keep going until you only have numbers that can't be broken down. Okay. So I'm going to replace 120 with all of those numbers I circled. 5 times 3 times 2 times 2 times 2. Next up, pairs, triples, or 4 of a kind. Which one do we need for this guy? Pairs, triples, or 4 of a kind? Pairs. Circle pairs. There's only one pair. So I get to move a 2 out in front. What does the 2 and the 40 do? Multiply. We get 80. What's left? 5, 3, and 2. Multiply those. 5 times 3 is 15, times 2 is 30, and you are done. 30 doesn't have any pairs, so we can't move anything out. So the only thing difference there, 6 is going to be the same way. We have to multiply first. Okay? 6 is the same way. The only difference with 6 is that it's to the third power. Third roots, I should say, third roots. Okay? Third roots. So this guy has a third root, and this guy has a third root. So I can multiply them together. I'm not going to do that yet, and there's a reason why. When I multiply 108 times 4, what's going to happen to those numbers? They're going to get bigger, right? I know my first step. My first step is to break down. I don't want to have to break down that big number. I'd rather break down 2 small numbers than 1 big number. Okay? So what I'm going to do is this. I'm going to put everything underneath the same root. 108 times 4, and then I have d to the 5th and d to the 5th, right? Everything underneath the same root. Okay. Okay, so now I have 2 numbers to break down, 108 and 4. Well, luckily 4 is easy, just 2 times 2. So let me break down 108 and 4. 4 is 2 times 2, done. 108, 54 and 2. 54, 9 times 6. 9 is 3 times 3. And 6 is 3 times 2. Okay. Put all those circled back. Put all those circled back. So I got 3 3s and 4 2s. And then d to the 5th and d to the 5th. D to the 5th times d to the 5th is going to make d to the what? 10. Yep, collecting powers. When you multiply, you collect powers. What am I circling here? Pairs, triples, 4 of a kind. Triples, circle triples. So I got a triple 3, triple 2, and then D, I'm going to have some triples as well. So I can move a 3 out, I can move a 2 out. I got a 2 left over on the inside. How many D's can I, how many triples of D am I going to have? Easy for me to say. I'm going to have 3 of them, right? Okay. Are any going to be left over? 1. There you go. Let's simplify. So I get 6D to the third root 2D. Right? Because that D right there is D, 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 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? And that guy had 1, 2, 3. That's where I got the D to the third. Alrighty, guys. One more, we're done. One more, we'll be done. Okay, so the last one is just division. So we have a pre-step. Before we can start breaking things down, we have a pre-step. Well, our pre-step before was multiplying. What do you think our pre-step is going to be now? Division. So I'm going to put everything under the same house like I did before. Put everything under the same house since they both have a root, a square root. You have a square root, you have a square root, put them under the same house. Okay. So numbers first. How many times does 9 go into 180? Or how many times can you divide 180 by 9? 20. Good. Okay. Done with those guys. I have x to the 9th on top divided by x to the 4th. When we multiply powers, what do I do with the powers? Collect them, combine them, right? What do you think I'm going to do when I divide? Take away. Good. Take away. So if I have 9 powers on top and I take away 4 powers from the bottom, how many powers are going to be left? 5 powers and then 4 powers of y. Now we can go to step 1. Now we can go to step 1. Break everything down. We're looking for pairs. So we got to break down 20. So instead of 20, I have 2 times 2 times 5, x to the 5th, y to the 4th. Look for pairs. I have 2 that can come out. How many x's can come out? How many pairs of x? 2, right? X squared. How many pairs for y? 2 again, yeah. What's left over? I got a 5 and an x, yeah. Y is done because I took them all out. You were done. That's it. Okay. So the big thing is breaking down What am I looking for? Take them out, leave them in. That's the big thing there. Okay. All right. So what I want you to do is tape. Tape should be in the back. So if you're in the back, just look behind you somewhere, grab a thing of tape.